Hello, my name is Rich Howard, owner of Architectural Builder Supply, and this video is to bring you a closer look at the Bommer 7811-603 horizontal spring pivot with floor plate, medium duty, hold open, in a 603 zinc plated finish. So this is the business end of the double acting pivot. Give you a closer look at that, then we'll start talking about it all. Floor pivot here, pardon me, the floor plate, okay. Spring assembly here, adjusted with the tension collar here, and I'll go over that in a moment. The hold open mechanism is achieved with these rollers and this hub that has a bird's mouth shape cut out to it, and I'll go over that in a moment as well. So here's the bottom spring assembly. Then the rest of everything that you're going to get, you'll get two finished plates, and they're identical. 603 finish. So that's going to be a zinc plated finish. You can see it's got a brushed texture to it. Okay. Zinc is nice because it's corrosion resistant, better than your average sort of finish. Plus it ends up at times being a lower cost version of a satin chrome. Okay, you're going to get a heel plate, and I'll show you how that's going to work out in just a few. You're going to get your top pivot assembly, kind of going to look like that. Okay, header portion, your door portion. You're going to get a tension rod. That's for setting the spring tension. I'll show you that in a moment. You're going to get a whole mess of screws for attaching everything. Top pivot, bottom pivot, to the floor, everything. Unit to the door, of course. So that part of the video gives you just a visual overview of the item. This part of the video is going to talk about the general mechanics of it, basically, and then the third part, which we're going to do next, we'll talk about the actual machining and installation of it. So before we get to talking about the machining, basically this is a Bommer 7811, which is a medium duty, and they have light duty, which would be like an 01. Then they have heavy duty versions, which would be like a 7813. They also have these available in a jam bracket as well, so you can mount it to the frame. This is a hold open version. I said I'd show you that, so here we go. So as the door goes through its cycle of opening and closing, as I try to twist that back there, you can kind of see that there's a, really can't see it. You can see that there's a, on the inside of this hub, pardon me, this part right here, I'm going to open it, and as you see, there's a, well, you can't really see it, but there's a bird's mouth sort of preparation. If you were to push that open far enough, and I can't do it with my hand, it's just too strong of a spring to do that, that bird's mouth here is going to rest over these rollers, and that's what is going to allow it to hold open at roughly an 85 or 90 degree opening. Okay. The spring tension is set with the tension rod going into the tension collar here and turning that, clockwise or counterclockwise, and that action will of course allow you to set the tension on the spring. You can continue to do that to the point where it makes sense. Okay, my hands are in the way, I realize that. Okay, that's how you set the tension. This is for doors of approximately 90 pounds, okay, up to 3070 typically. We'll work on 1 3/8 or 1 3/4 doors. Okay, obviously a double acting sort of item. You're going to see these very commonly, I see them very often in residential applications between a dining room and a kitchen. Okay. I've seen them installed after decades of use, still working quite frankly, like the day they were put in. They work very well. Available in several different finishes, not only zinc, but all the commercial finishes that are available. Hold open is a very common option, as is non-hold open, of course, that as well. If you have lighter doors, look for your 7801, and if you've got heavier doors, look for your 7813 version. If you have any questions on which model to use, please feel free to reach out to us. Time to talk about machining. If you're going to prep the door yourself and you've not done it, stick around. If you have no need to know how to do that, the rest of the video is not for you, other than to say, if you have any questions, reach out to us. All right, so below this video is a link to a piece of paper called Template, and there's another one called Instructions. And they really have the same information on both in terms of my part of the discussion at this point. So I'm going to be just working with the instructions since it incorporates everything that I'm about to say. I have machined for these more times than I've counted, and they're easy to do. They're not, they might be intimidating, I suppose, if you've never done it or if you don't have the right tools, but they are simply easy to do. There's no question about that. Looking at the instructions, you see that you've got steps 1 through step 6. Okay. Before we start talking about them, every time I've machined these, it's been with the proper tools, or at least the proper tools for a carpentry workshop. Routers, router bits, drill bits, Forstner bits, etc. If you don't have those items, this might be something that you're going to want a door supplier to order from the factory already machined, someone with the right kinds of tools. Anyway, so step 1, it is important that you achieve that 1.5 inch radius that you see in step 1. That edge of the door is the pivoting edge of the door. It's important that you achieve that radius if you want to install the door per the instructions, dimensionally per the instructions. If you just peek down to step 2 for a moment, you see the 1/4 inch dimension. If you've not achieved that 1.5 inch radius, that 1/4 inch will not work. You're going to need to increase that, maybe to a 1/2 inch. It depends on the thickness of the door, of course. But your margin between the jamb and the door will have to be greater if you're not radiusing the door. And you can get the idea that the outside of my fist, if that is a door that's not been radiused, think of the top row of tile in your bathroom, how it's curved. That's a bowl nose. If you doubled it, that'd be a radius. If you've not radiused, you can see where you're going to need additional room, okay, between the door and the jamb. Radiusing a door like this, if you're a fella who doesn't make a living in carpentry, that might be a challenge because you really need a router to do that. All the times that I've machined for this, I've done it so many times, I had just a router and a bit set up to do only this, and it was set to that and never changed unless it was time to sharpen the router bit. I'd have one horse router with the base. I cut the base out, a large hole in it, so that I could get basically a 3-inch diameter round over bit into it with a bearing. Okay, and I'd set that up, very large bit. Get the door set on sawhorses, clamp it down, get the depth of it set so that I was going to achieve a symmetrical radius on the door. Okay, depends on your door thickness. And I'd put that router down at one end, and I would just bring it down. And as I got to the end of the door, I wasn't putting any pressure or force this way because I didn't want to unintentionally round off more than necessary. But I would just exit off the door like that, and I would do 2 passes. One does the majority of the work, and the second one is intended to just clean it up and make it look perfect. And that's the idea. Any more than that, then you're running a risk of taking off more than you probably should. Anyway, you want to get a nice, make sure that's all clean. Because any chatter in your router is going to leave marks on the door. You're not going to want to make that. You're going to want to be real straight, real even, real consistent. Then at that point, take the door, turn it over, clamp it back down and do the same thing. And if you've got this bit, you might as well just do the opposite end of the door too, the lock side, okay? Because at that point you'll be able to get your margin down. You can get it down below 1/4 inch. You probably get it to 1/8 of an inch, depending on how tight of a radius you make. You know, your radius can't be any greater than your door thickness, okay? Because then what will happen is your radius isn't aggressive enough, and you still run the risk of bottoming out when you try to open the door. So, in talking about that, you're probably going to be starting with a frame, inside frame width. So, you know, if you're going to radius both styles, let's say it's 36 inch, deduct 1/4 inch, deduct 1/4 inch, now you're at 35.5. That could be a good net size. If you're radiusing both, I know that you can increase that margin a little bit. That's a hard part, and probably tool-wise, it's the hardest part to accomplish. But once you've got that, it's going to be in real good shape. However, if you're dealing with a veneered door, and many doors are obviously a veneer construction, keep in mind that when you take off that much of the door, you're going to accentuate the visual aspect of the layers between the veneer, the cross banding, any backer that's going to be there. Okay, so keep that in mind. Step 2. Step 2 is a real easy one. Talks about installing the top pivot. Top pivot consists of 2 parts, the header portion and the door portion. Okay, the machining starts out identical for both. When I've machined these, looking at step 2, you've got 1.5 dimension from the edge of the door to the center line of that hole, that center hole. Mortise 1 inch diameter, top of door and header, 5/32 deep as shown. You can see that you've got 5/8 of an inch center line from that 1 inch this way and that 1 inch this way. When I've done this, being lazy, wanting to do it the easiest way and cleanest way possible, Forstner bit is how I've always done it. I would take a 1 inch Forstner bit, I'd mark my 3 center holes, and I would just zip it in, just like that. Clean hole, no mortising to do. Do that to the top of the door and to the header. Obviously in the door, you've got to drill, the second part of step 2, you've got to drill a 5/8 hole, 5/8 deep, to allow for the stud to come down. Okay, so your 1.5 dimension is really important. That's where this is going to go. That's based on a 1/4 inch margin, obviously. No, it's not based on that. It's not directly based on that. But keep in mind, from the edge of the door, 1.5 is what they want. That's important because that is in step 3. You've got to make sure that your vertical axis of pivoting matches up with the bottom. We'll get to that in a moment. So step 2 is mortising and, quite frankly, just attach the top pivot. And at that point, you're done. Put the portion in the header, put the door portion in, you're in good shape. You're going to want to mortise that cleanly. You will see a little bit of it if the door is held open at 90 degrees. You're going to see part of that staring down at you. Okay. Now, step 3, first time I looked at that, I thought, oh my gosh, that's very complicated. Bottom line is it's not. You need to make your door fit this. That's all you have to do, and how you go about that is your business. When I've done it, I've tried to use a router as much as humanly possible because it gives a very clean finish. Okay, but the bottom line is, from the floor to the top of this prep, it's 3 5/16. We're in step 3 now. Look to the right of the top drawing in step 3. You see 5/32 from the floor to where the bottom of the door is going to be more. Forgive me. Start over. Bottom of the door to the top of this mortise is 3 5/16. Okay. 5/16 thick preparation for this. Okay, and then from there, you can draw out the rest of your dimensions. 8 3/8 over, 8 3/8 over, 1 7/16 from the bottom of the door will give you all this body. Then you're going to have to mortise for this little tongue over here, 5/32 by 13/16 wide. The only other thing you'll have to do in the bottom of the door is to do that groove that you can see there, and that's because that mechanism travels as the door opens and closes. Okay, so you can envision that. Want to mention 9/16 of an inch undercut is what, you know, this is all being based on, and then 1/8 of an inch at the top of the door. So the door height, let's say 80 inch, allow 1/8 at the top, 9/16 at the bottom. Okay, so 11/16. So you're going to be at 79 and 5/16 would be a net door height for that. Keep that in mind. That's an important. That's coming off the template. That's the one thing that's really not noted out on the instructions that I've noticed. After you've prepped the bottom of the door, this should fit into it. Okay, you should be able to get this to the bottom of the door, and everything should square up real nice. You can then attach that to the bottom of the door. Okay. That heel plate we talked about earlier, I didn't mention it, but it's curved. And it's curved because they are certainly assuming that you're going to radius the edge of the door. Okay. You've got the spring unit attached to the bottom of the door, which is really step 4. Okay. You're going to want to make sure you've got everything calculated. You see in step 4 where it says 1 3/4 from the jamb to the center line of the pivoting axis. That's, you know, based on a 1/4 inch dimension. And if you take 1 3/4 less 1/4 inch, 1 1/2, which is a reference to step 2. At that point, step 5, okay, is going to get you where you need to be. Tip the door into the opening. You're going to want to mark your holes in the floor. You're going to want to get an idea that everything is margined correctly. You've got margin between, equal margin, and that the door is actually going to open. You want to mark that. The floor plate does have slotted holes to allow a little bit of play with that. Not too much, but a little bit. Okay. Once you get it all marked, you can drill your holes in the floor, get the door back in, secure it down. Okay. At that point, obviously test your operation and make any adjustments necessary. Once you're done with that, you're going to be attaching your heel plate. Okay. And that's just simply going to attach right to there. There's a hole in that. And then your face plates are going to, you know, just dress over that. Okay, so that you get a nice clean look finish on that. On both sides. Before you do that though, set your tension. Okay, get it attached, set your tension using that black piece of steel, that tension rod. Make sure it operates the way that you like it. You're in good shape. And again, in these bags are all the screws. You're going to have 8 screws for the face plates. You're going to have 4 screws to hold the unit onto the ground. You're going to have 8 screws for the top, 4 screws for the top pivot, 1 to hold that heel plate onto the edge of the door. It's a machine screw. And that's going to be everything. Really nice quality item by Bommer. I don't know how many decades they've been making these, but it's been, I think I've got someone for sure in the 1940s, I believe. If not, I mean, my great-grandparents' home was built at the end of World War II or during World War II, and there's, when I saw it in 1988, it worked like the day they put it in, you know, 40 years before, so I know they're at least that old. Bommer's a full-line manufacturer of this material. They're noted for this stuff. They're noted for those double-acting spring hinges that you see, the 3029 series. They are a full-line hinge manufacturer. You know, regular mortise hinge. They've got their logo on down there, and while you can't see it, what's right above there, it says Made in USA. A fact that Bommer is quite proud of, as am I to represent them. If you have any questions on the Bommer 7811-603 double-acting pivot, medium-duty, hold open in a zinc finish or any other Bommer product, please feel free to reach out to us. Thank you.